Woohoo, we are recording, and this is 7.2 multiplying and dividing rational expressions. Woohoo, otherwise known as fractions. Yay! So, we're going to start off with a review item, I hope, called reciprocals. So, find the reciprocal of 2/3. And I know that's a little bit hard. So 2/3, it's a little bit hard to see it, so let me write it a little bigger. And the reciprocal just means to flip it upside down. So the reciprocal is 3/2. Now notice I use an arrow, not an equal sign, because usually a fraction is not the same. It's not equal to its reciprocal. I can think of one number where when you flip it upside down, you get the same number. I can actually think of a bunch now that I think about it. Can you think of any? Woohoo! Yeah, if the top number and the bottom number, the numerator and the denominator, if they match, then the reciprocal will be equal to the original fraction. Most of the time, though, you're going to get different numbers, so you're actually going to change the value of the fraction to take the reciprocal. Okay, find the reciprocal of x over y. So if I have x over y, the reciprocal would be y over x. Woohoo! So, just a little review on my little card here, the handy dandy card I made. Top number is known as the numerator, bottom number is known as the denominator. A reciprocal takes the numerator and the denominator and has them switch places. So the bottom number comes up, the top number goes down. And these are usually not equal. These two fractions will not be equal to each other. Okay, so let's find some reciprocals. 1 over x, the reciprocal would be x over 1, which the interesting thing there is that you can also write that as simply x, which is kind of cool. Anything over 1 is just itself. And if I have -1/3, the negative doesn't get affected at all by the reciprocal. So I've got negative, and when we flip it upside down, 3/1, which is -3. So far, so good? Okay. Now, what if I get an expression like x plus 8? Now, if you start off with something that is not already in fractional form, it's going to be hard to take the reciprocal. So what I'm going to do is I'm going to write it as a fraction. Now, there are many ways you could interpret the request to write it as a fraction, but what I'm going to do is just simply write as x plus 8, the whole thing over 1. So I'm going to take the whole expression, write it over 1. This is always legal. You can put anything over 1 if you would like it. Even 0 goes up over 1. And then, notice these two are equal. Then I'm going to write it as the reciprocal, 1 over x plus 8. Woohoo! Woohoo! Awesome. So basically reciprocals are just flipping fractions upside down. Why in the world are we going to use it? Well, there's a hint here. When we get to dividing, we're going to need to know this. So we go through this review first. But before we get to division, I'm going to move these guys to the side. Pardon me, Sharktopus. And we're going to come down here to multiplication of fractions. Multiplication of fractions is performed by multiplying across the top and across the bottom. Multiplication loves you. Multiplication loves you so much. Addition and subtraction, they hate you. They hate your guts. I'm sorry. It's not you. It's not personal. They hate everybody. But multiplying is really a lovely experience. Everyone just has the best time. So if I'm going to multiply green triangle over pink square times yellow star over blue wiggly guys, I think I meant waves there, then notice that I multiply across the top. I get green times yellow on top and pink times blue on the bottom. And the two denominators don't have to match, which is really amazing. Spoilers, this does not happen all the way through. But with multiplication, you can multiply any two fractions. So if I have 1 over x times 3 over y. That means I go across the top, 1 times 3, and across the bottom, x times y. So I get 3 all over xy. Is that not just beautiful? It's just a big old love fest with multiplication. Multiplication loves everyone. Okay, 1 over x times x over y. Now, some of you who have had fractions before, you may see something that's possible, and I'm not going to do anything with it right now, but you could. Those two x's are winking at each other. I'm going to go to the next step and say, okay, anytime you have something up top which is multiplied that matches something on the bottom that is also multiplied. This all has to be multiplied. Notice there's no plus or minus. If plus or minus are there at the party, you know they're going to make trouble. So plus and minus, totally different situation. But as long as everyone's multiplication, big old love fest, we can go ahead and cancel those two because it's kind of like redundant. We put an x on top, we put an x on the bottom. It's like, you know what, those x's didn't actually need to be there. We appreciated that they showed up, but then, you know, it's like, hey, thanks so much, and go off and have a lovely day. So I actually get 1 times 1 up top, 1 times y, 1 over y in the denominator. Now, if you did not see that, can you guys see this? Yes, towards the bottom. If you did not notice that you could reduce it and you multiplied, you'd get x over xy, and then you go, oh, right. If I have something, if I have a factor that appears in the numerator and in the denominator, I can cancel it with my red pen of destiny, and I get 1 over y. So you'll get the same answer, and you can reduce it here. You can reduce it here. You can reduce it after you're done multiplying. It's totally up to you, whenever it makes the most sense. Okay, let's go to page 2. I wonder what excitement awaits. As you can tell, I've had some coffee this morning. Maybe I've had too much coffee this morning. I don't know. Is there really too much coffee? Is that really a thing? I'm not sure. Yeah, much like, is there really too much math? No. Okay, division. Oh, and I wrote blah, 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 blah. Unfortunately, sometimes I write these things. Division of fractions is performed by taking the reciprocal of the second fraction and then multiplying the new fractions, which for most people, if I read that out loud, sounds like blah, 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 blah. So let's look at a picture. Pictures are good for me. If the words worked for you, awesome. So just hold for a second while I do the picture thing, because this is what I would need to see. So dividing, I tried to make it nice and colorful. If it's too colorful, I apologize. As I said, lots of caffeine went into these this morning. If I'm dividing two fractions, see, I got that division symbol there. It turns out you can't divide. I know. Everyone always says, let's divide some fractions. You know, your friends are going to be like, hey, you want to divide some fractions? And you need to say, no, wait, just say no to division. We can't be dividing fractions. We actually need to multiply fractions. So instead of dividing, we're going to change it to multiplication. But obviously, you can't just multiply when you're supposed to divide. So how are we approaching this? Well, it turns out, and though this is not something I'm going to show you in this video, I am happy to show it to you. Like at office hours, you can ask me, or maybe I'll even make another video that explains this. It turns out that when you're dividing by a fraction, you actually get the same result if you multiply. And here's where we went over the reciprocals at the beginning. If you multiply by the reciprocal, so we take the star over waves and we flip it upside down. So it becomes waves over star. So you flip the second one. Remember to flip the second one. That's the big part. So that's it. There's not actually any true division of fractions we're going to do. We're going to always switch it to multiplication. Because again, multiplication loves everyone. Woohoo! So, shall we practice some division of fractions? Yes, let's do it. Okay. 1 over x divided by x over y. Now, here's a problem with division. Division, especially if you've been doing a bunch of multiplication, will kind of fake you out sometimes. See how these two x's are winking into each other like we should cancel them? Do not do this. Remember, division doesn't actually exist. Don't do anything with the division. What we have to do is rewrite it as multiplication. The first fraction stays the same. The first whatever comes first stays the same. And pardon me, sharktopus. And the second fraction flips upside down. Reciprocal. One of the hardest words in the English language to spell. Seriously. Okay, so we've got 1 over x divided by x over y equals 1 over x times, and then we took this and we flipped it upside down. Notice that in actuality, when we write it as multiplication, the x's are both in the denominator, so they can't reduce. They don't cancel. We get 1 times y over x times x, which is actually y over x squared. So not only are we not canceling the x's, we've actually got like double x's. It's x times x. Okay. Woohoo! Shall we do another one? And as I'm reading this, I'm realizing this is one of those, well, that escalated quickly moments. Apparently, when I was writing this up, thought, well, we could totally handle this. So let's go ahead. Let's see if we can handle this. Nasty, somewhat scary fraction, or not. You know, maybe you love fractions. That would be awesome. Divided by, and this isn't even a fraction. I mean, what are we even doing here? So much like on the first page, there's a lot that we need to work on with this. So I'm going to rewrite. It's going to be 2x squared y all over 3y squared. And as I say that, I notice, oh my gosh, someone has left us a mess. Someone hasn't been reducing. So we're going to have to deal with that. But I'm not going to deal with that right now. All I'm going to do is write 4xy as a fraction. So it's kind of, it feels a little bit... It's almost like cheating. To make something a fraction, you just stick the whole thing over 1, but it totally works. And again, we've got some y's that are kind of winking at each other, but again, you say, no, 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 not division. You can't reduce with division. So 2x squared y all over 3y squared times, and now I'm going to take the reciprocal, 1 over 4xy. So I switch it into multiplication mode. Now, how you reduce is up to you. Could you reduce everything here? Yes, you could. The problem is if I did all the reducing in here, it'll mess this up, and so anyone reading these notes is going to find it a little bit hard to read. So I'm going to go to the next step. You could reduce here. I'm going to write 2x squared y times 1 all over 3y squared times 4xy. So we've got a single fraction, all multiplication, none of that nasty addition and subtraction stuff, and I can go ahead and start reducing. So let me get my red pen of destiny here. Okay, anything on top with anything on the bottom. So this 2 reduces, cancels with this 4 and leaves a 2, which could you have done it up here? Absolutely. Could you have done it here? It's a little tricksy in here. I would encourage you, even though, yes, it's possible to reduce in division form, it's considered kind of in poor taste. I wouldn't do that. Write it as multiplication first. Okay, x's. Let's see. Well, the x's are kind of tricksy. I've got an x here, which cancels completely, and then I've got this x squared. Now there are 2 ways to do this. Either I can just cross out the squared and leave just the x, or you could cross out the whole thing and write in an x. I mean, it's up to you. Again, this is going to be style. And then I also have this y, which cancels either with this y or with these 2 y's. Totally up to you. Will not change the results. Now, I realize that here it looks like I've got 21, so I probably should put some multiplication signs in just so I don't forget. And let's see if we can clean up what we've got. I think I've end up with just an x up top, x times 1. And then down here, I think I've got a 3 and a 2, so I've got a 6, and then y squared. I'm going to go up to this form and double check. I've got x times x up here and an x down there, so I've just got one x left. I've got one y on top and 3 y's on the bottom, so that leaves me with 2 y's on the bottom. I think that's correct. Woohoo! I'm actually going to put a box around this one. I should have put a box around the top one, huh? It's like, yay, we did it. We got it right. Woohoo! Okay, you guys ready to go to the third page? I know. It's exciting. There's just when you think you've done all the math, there's more math. There's always more math. Oh my gosh, that's like the theme of grad school. There's always more math. Yay! Okay, multiply or divide and simplify. Dun dun dun! I've got 1 over x times y over y plus 1. Ooh, tricksy. Addition hates you. I'm sorry. It just does. It hates everyone. Addition is not nice. Addition is just, ugh. Just seriously, ugh, I cannot even deal. So we're going to multiply across, but can I cancel this y? No. And why not? Well, because addition came to the party, and so nothing reduces, and it's stupid, and ugh. Oh my gosh. Addition, am I right? Just, ugh. Notice that when I multiplied across the bottom, I wrote x times the quantity y plus 1. Again, addition is really gonna just mess everything up. And I end up with y over x times the quantity y plus 1. Now, I personally think this is a superior form. However, every now and again, you may want to actually multiply. And so you would get x times y and x times 1. Does that make sense? So it's possible you could multiply out, or you could leave them factored. Do the y's cancel? No, they don't. Because this factor is actually not just y, it's y plus 1. So it's slightly different. It's like 3 and 4. Or 12 and 13. So they don't match exactly. They're one off. So you can't reduce. I know, seriously. Oh, addition. Ugh. Okay, let's go on to the next one. Uh-oh. Is it the same problem? It looks like the same problem. 1 over x times x over y plus 1. Oh my goodness. This is going to be so much more satisfying. Because when I multiply across, I get 1 times x, and down here I get x times 1 y plus 1, which looks almost identical, right? Except these two, and I'm going to emphasize this by writing multiplication. You don't have to write the multiplication. You can just leave it as implicit multiplication. But since this is multiplication and this is multiplication, I can cancel the x's because they cancel very cleanly. And then I end up with 1 over y plus 1. Now, could I have canceled right here? Absolutely. You can cancel here, you can cancel here. And just, just to explain, I always try to leave the problem itself unmarked. So if I ever have to go back, I can see exactly what it said. So I can double check if I misread it, because, I tend to misread things a lot. So I need to make sure I can go back and check. Okay, number 3. And then I think we're going to stop for this one and then go on to the next video for the rest. Oh my gosh, look at how big and juicy this is. This is going to be fun. Yeah, I know. Sometimes my idea of fun and your idea of fun might not be the same thing. But let's give it a try. Now, you've got a couple of options here. I'm going to go ahead and multiply them out. So I've got 20y times 6z to the 4th all over 9z to the 7th times 5y squared. Now, a lot of stuff is going on there, so you could go ahead and reduce in this form, Or you could break it down a little bit. So this is optional. You don't have to do this, but this is an idea. Since I'm going to cancel 5, I'm going to break 20 into 5 times 4, y, and then I'm going to break 6 into 3 times 2, z, 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 z. See how I wrote 4 z's? And then 9 is 3 times 3, 7 z, 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 z. 1, 2, 3, 4, 5, 6, 7, 5, y, y. Now, do you have to do this? No, absolutely not. But sometimes, I just wanted to point out that sometimes you can do this, and you can go ahead and go in and say, oh, wait a minute. So I've got a 5 here and a 5 there. They cancel very cleanly. There's a y here and a y there. Cancel. 3 here, 3 there. And then I've got 4 z's. 1, 2, 3, 4. I can cancel out 1, 2, 3, 4. Notice this follows that there are rules of exponents, right? If I've got 7 down here and I've got 4 up here, I subtract to get 7 minus 4 gives me those 3 z's. So do you have to do it this way? No, just wanted to show you it's an option. Let's see, I think I'm going to go through and circle what's left, because this really was such a juicy problem that there's a lot of stuff going on here. Oh, there's an extra y there. Let me double check. Okay, and so I end up with, I think, let's see, this is going to be, everything up there cancels except for the numbers, so I end up with 8 all over 3y z cubed. Let me double check. The 20 times the 6 is 120. The 9 times the 5 is 45. And so I can, yeah, that'll do it. I'll end up with 8 over 3, yes. The y's cancel, I end up with a single y in the bottom, yes. And I end up with 3 z's in the bottom. I think we've got it. Hopefully there aren't any mistakes. Fingers crossed. And we made it through. Quite a juicy problem. Another thing I can mention, when you get a really juicy problem where there's a lot of canceling, you could do a little canceling and then rewrite the problem and then do some more canceling. It doesn't all have to happen in one place. So if you don't have enough space, just keep canceling in successive steps. Okay, Godzilla and Sharktopus are very proud of you. You did great. Woohoo. I'm going to go ahead and put the card up here in case it's helpful. If it's helpful, you can freeze the frame and print out your very own fraction cheat sheet. Woohoo. You guys are awesome and amazing. And I hope you have a great day. And I hope you get lots of vegetables and lots of sleep and lots of exercise and hydrate and math on.